All right, this video is the intro for AP Calculus AB Section 2.3. We're going to be looking at a couple of new rules in this video. First one is the product rule. Let's just do a little bit of remembering here on this first section. Take a look at our first three examples here. I encourage you to look at these and try these on your own. But here we go. So with number one, this is just a regular old straight up power rule. So I would write dy dx is equal to 5 times 2 is 10, x to the first. With the second one, this is a constant multiple rule, of course, with sine. Maybe we remember from last time the derivative of sine is cosine. So we'd write dy dx is equal to 4 times cosine of x. So you might be tempted in number 3 to do something similar to that. You might be tempted to write dy dx is equal to 10x times cosine x, maybe, something like that. But that is incorrect. The reason is, we're going to look at this here today, the reason is that this is a product. This is one function times another function, and so that, of course, is different from one function plus or minus another function, and so we can't use the same rule. It just simply doesn't work. We've got to use what we call the product rule. So I'm going to show you the symbols here. The symbols are important. I'll show you an easier way to remember it. So here we go. So d dx of f of x times g of x looks something like this. F prime of x times g of x plus g prime of x f of x. That's how some folks will write it. Let me give you a way to remember it. That's not going to be a great way for you to remember it. The easiest way to do this, just a little saying. We're going to remember 1 d2 plus 2 d1. So nothing brand new about that. Lots of folks will use that. I think it's a great method on remembering how to do the product rule. So 1 just refers to the first function being written. D2 stands for the derivative of the second function. Of course, plus just means plus, and then 2 would be the second function. D1 would be the derivative of the first function. All right, so we're going to do one example of this product rule. Here in number 1, says g of x is equal to root x times sine of x. We're going to do a little bit of rewrite here before we actually differentiate. We're going to rewrite that radical as x to the 1/2. So it's going to be g of x is equal to x to the 1/2 times sine of x. So we've got to recognize, and I think I wrote this off to the side here, that you can see that recognizing the product rule is really important, and sometimes it's difficult. Sometimes people don't see it. So we'll do our best here to help you see it each time. There's some good practice at the end of the chapter to help you with that also. All right, so here we go. G prime of x is equal to, we're going to do 1d2 plus 2d1. So 1 would just be the first function just written out as is. So 1, and then d2 would be the derivative of the second function. So that would be cosine of x. So there's 1d2 plus 2. That would be sine of x, such as that second function rewritten there, times d1, so that would be 1/2 x to the negative 1/2. Of course, there's a lot we could do with that as far as manipulating and maybe making it look prettier, but we don't have to, so we're just going to leave it as is. And again, take note there, off to the side there, the struggle I see the most with this product rule is recognizing it. So if you do see a times, I strongly suggest, maybe like circling the multiplication symbol there, highlighting it, drawing an arrow to it, writing, that's a product. I don't know, making some kind of a note to yourself, trying to help yourself remember that you got to use the product rule. All right, our other rule for the day is the quotient rule. So the product rule was to help us to differentiate a product, so the quotient rule will be useful when trying to find the derivative of a fraction or a quotient. So let's write it out here. D dx of f of x over g of x is equal to it's a pretty big mouthful here. And of course, you can see there's an easier way to remember this. I like this one even better than the 1d2 plus 2d1. It'd be a big thing for you to try to memorize. I think it's best to try to remember it this way. So here we go. Remember this little saying: low d high minus high d low over the square of what's below. And hopefully you can see how that goes with what I wrote up there. And this is just a good little way of remembering the quotient rule. So we're going to do a little practice with this. So number 4 is what we're going to practice with. So notice the numerator and the denominator are both non-constant functions, and so using the quotient rule is certainly a good way to do this question. So feel free to try this on your own if you want. Pause the video and watch. In any case, here we go. Number 4. So I'm going to write this, y prime equals. This is ready to go as it is. We're going to go low. So the low function is 5t minus 3. It's the one that's down low in the fraction. So low, d high. Well, that would just be the derivative of the higher function. So the one in the numerator. So d high would be, in this case, 2t. So low d high minus high, that's just the numerator. D low, the derivative of the denominator, would just be 5 over the square of what's below. So it would be 5t minus 3 quantity squared. So just another thought here, if the little saying doesn't rhyme, you did it wrong, so it should be low d high minus high d low over the square of what's below. So if you said high d low minus low d high over the square of what's below, you can see that it doesn't really rhyme, so you actually said the top backwards. And of course, the ordering in the top really matters because it is subtraction. All right, finally we have a little check for understanding here with the product rule and the quotient rule. So I encourage you to try this by yourselves and just watch the video and make sure you did it correctly. So here we go. It says find g prime of x if g of x equals that whole thing right there. There's some f of x's scattered in there, so we'll talk about what that means when we get to those. We really don't know anything about f of x, we'll just have to treat it symbolically. All right, so here we go. G prime is equal to, well, the first thing I come to is that fraction. And so perhaps the best way to do the derivative of that would be to do the quotient rule. So here we go. Low is just f of x. D high would be 6x, so low d high, minus high. D low. How would we note d low? Well, we're just going to write times f prime. That's really all we can do. Low d high minus high d low over the square of what's below. So that would just be f of x squared. All right. So that next term, 8 over x, this is actually from a previous section. I thought it would be worth throwing in here. I'm going to rewrite that as 8 times x to the negative 1. It will allow me to use the power rule instead of using the quotient rule. You might be tempted to look at this and think of this as a quotient rule, and you could. You could definitely do the quotient rule here. But because the numerator is just a constant, it's definitely more efficient to just use the power rule by flipping the x to the top. So, hope that makes sense. So when I use the power rule, it's just going to be minus 8x to the negative 2. And then finally, my last term here is, of course, a product. I hope you recognize that. So I'm going to write minus, I'm going to put this in parentheses, and I'm going to go 1d2 plus 2d1. So 1 would just be f of x. d2 is just 6 plus 2. So that would be 6x minus 5. It looks like I'm running out of room here. Let me try and make myself a little more room here. So 1d2, so that would be f of x times 6 plus 2, 6x minus 5. d1 would just be f prime. Squeeze in a parentheses there. Sorry, kind of ran out of room. So a key idea here, of course, is that eventually this minus sign would get distributed to both terms on the inside. But at this point, we've completed the process. We've answered the question, so I think we're good to go. All right, so I'll see you in class. We'll do a lot of practicing here with the quotient rule and the product rule.